on this episode of Life in a Tide Pool. Find out why these animals live in this narrow band, why they only seem to grow in clumps, and why you should never eat local shellfish when the ocean looks like this. Welcome everyone. On today's show, we'll learn about one of the most common animals that live in the tide pool area. I'm referring, of course, to Mussels californius, or commonly known as the California mussel. Very much like the ones I see here and the ones behind me on the rocks over there. Mussels are one of the most common animals in that they are easy to see, touch, and look at. Most people know that mussels have two shells, or two halves. They attach to rocks and pretty much they don't move around at all, so it makes them pretty easy to see and look at. They seem to be everywhere and almost evenly distributed. But if you look a little bit closer, you'll begin to notice a pattern about where these animals live. Notice that they are very common in this area, but they are not as common or don't exist at all in other parts of the area. For example, we see them right here, and we see them on some of the flat places a bit over here. We don't see them very high in the tide pool area. We also don't seem to see them very low in the tide pool area. So why is this? Why are they common in just these certain areas? Why don't other animals live in these areas? We have some examples here, but for the most part, they don't. To understand the reasons why mussels are so common and so successful in these certain areas, we must first learn a little bit about their life history, and a great place to start is the Santa Monica Pier Aquarium. Tell us a little bit about this tank over here.
Sure, this is our Rocky Reef tank, and we have a lot of really cool animals in here. We have three California moray eels, and yes, and they're kind of just chilling out right now. But we also have the California spiny lobster in here, as well as, and I don't see it right now, but the Garibaldi, which is our state marine fish.
Right. So how do you feed the animals, especially that moray eel over here?
The moray eels, we actually have to use little little claspers and put it down close to their mouth, and that's how they take it from us. Right, I see.
Yeah. So who gets to feed that moray eel?
Our aquarium staff and our interns.
The interns,
yes.
Right? Everyone's going to have interns.
Yes.
This is wonderful. I also see over here a marvelous touch tank. Would you mind showing me a little bit more about the touch tank?
Absolutely, let's do it.
Come on. I want to actually learn more about some of the mussels in your touch tank that you have here. So I actually want to touch them, and I know I can, but I also know I have to touch them a correct way and have safe etiquette, right? Can you tell us how we can touch the animals here?
Absolutely. At the aquarium, we always have the two-finger, two-touch rule. So if you just kind of feel the back of your hand, that's a nice pet, that's a nice gentle pet. Those are the things that we ask you to do. If you use one finger, that's mostly for poking, but two fingers are nice to pet with.
So first thing I noticed about the mussels, obviously, is a very hard shell. But tell me about these little threads that I see in here. What are these little...
These little threads are called byssal threads.
Okay.
And these help the mussel to attach onto the rocks and stay put, because they don't have legs, they don't have anything that they can move with, and so they are a sedentary animal, so they stay put. And those byssal threads are very, very strong.
I have to assume that they're going to grow the byssal threads. They can make them during their lives, right?
They do. So it shoots out like liquid, and then when it hits the water, it starts to harden. Right. And so when it hardens, then it becomes really, really strong, strong as steel.
How do mussels feed themselves?
Well, they're filter feeders. So they open up their shells a little bit, and then they feed in the animals that we feed them here or in real life.
So that brings up a great question. How do you feed this mussel in this water here?
Yeah, so we actually take like little turkey basters and we put baby brine shrimp in here, and then they open their shells and they feed through that. And I bet you get some interns, right, to feed them? Of course. It's our interns again that feed them.
I noticed a lot of other animals over here. This, for example, what is this animal right over here?
This animal right here is a sea cucumber. This guy is in the same class as sea stars or the sea urchins. They're an echinoderm.
Echinoderms, which usually means hard outer shell.
It's spiny skinned, yeah. Okay. So it looks like they're spiny, but they're actually kind of squishy.
Okay. Yep. These mussels down here, I know that they're a very important part of the ecology. So who eats mussels?
Well, we eat mussels.
That's right, we do.
But also, we have sea stars that like to eat these. This is one of their favorite foods.
So I know when I'm out in the tide pools, I see these massive, massive beds of the mussels, and all around the edges I see the sea stars. So the sea stars are feeding on the mussels over there.
Absolutely,
right?
It keeps the population in check.
So if I didn't have any mussels, say humans ate them and stuff like that, there would be no sea stars.
It's a possibility. They would find something else to eat. They do clams or other things to eat too, but of course they wouldn't grow as high in population.
So this is a pretty important species in the intertidal zone, right?
Absolutely.
We call them indicator species, isn't that right, or something like that?
That is absolutely correct.
All right. Amanda, thank you so much for showing me around this tide pool. Have a wonderful time. Thank you very much.
Thank you.
When learning about any new plant or animal, I always like to see these animals in the wild. One of my favorite places to see mussels in the wild is White's Point, located in San Pedro, California. I'm going to meet a colleague of mine, Bruno Pernay, who is an expert in this field and will help us learn more about the life history of mussels. Before we meet Bruno, however, White's Point has some fascinating history that is worth exploring. The tide pools behind me in this area are characterized by this great big rocky bench area here, which is just loaded with marine life. There's mussels, barnacles, great little deep little pools. The other portion of the tide pool area over here to my right is characterized by these nice channels that have great vertical structures for marine life to attach to. Again, lots of diversity, loaded with life. The other reason I like this place is it's easy access. Plenty of parking over here for visitors to come explore and see the tide pools. So one of the more interesting features about this particular location is this foundation here. This foundation extends pretty wide over this area, and this is the remains of an old resort spa back in the 1930s. White's Point was devoid of all human life and habitation except for the occasional visitor in the 1900s. This, however, changed in 1890 when a group of Japanese immigrants who originally were working for the Pacific Railroad Company discovered an abundance of abalone and started a small abalone fishing business. They set up a small village and used small boats to harvest the abalone. This business lasted for about a decade before specific laws were passed that prevented people of Japanese descent from operating businesses such as this. During this time, however, the fishermen discovered several sulfur springs that produced a regular supply of hot water in the area. In 1915, an entrepreneur named Raymond Sepulveda, with the help of these very same fishermen, built a small hotel and a restaurant and a large swimming pool that was partially filled with the hot water from the nearby sulfur springs. The resort was updated periodically throughout the time with additional buildings and facilities. The Long Beach earthquake in 1933 destroyed the hotel and altered the underground geology enough to limit the hot water output from the sulfur springs to just a trickle that we see today. All that remains is just a few of these little pools like this, and you actually can see this milky white substance over here, which is part of the geothermal hot springs, and this is some of the very specialized bacteria that feeds on some of the nutrients that comes out of the water. So it's not very good if you're a marine life to live in this pool. You can see not many things is going to live. The other thing that you're going to see is it smells really bad. So what happens is the hydrogen sulfide that comes out of these vents causes this really nasty rotten egg smell. So again, this is about all that's left of one of the hot springs here that we can see, but very good evidence that this area is still geologically active. I found Bruno near the parking area, and we started to walk to the northern tip of the tide pool area. This location has two large deep pools that have hundreds of urchins, sea anemones, and much more. This is a great location as visitors can easily look into the tide pool and see the rich diversity of marine life. After a while, we left this tide pool location, passed by a few of the locals, and started to look at a new location to learn more about mussels. And I noticed there's a lot more mussels and there's some barnacles here. So why are they here and not back over there?
Well, I think we're probably a little bit lower in the intertidal, so these are covered with water a little bit more of the time, and also it looks like they're more directly exposed to waves here, so they might be, even when the tide is out, they might be getting wet more often.
Right, so more water, more food, we're going to sustain bigger animals and different kinds of animals, right?
Right, they're going to survive better.
If you're living in this very harsh environment, waves pounding on you, what are some of the adaptations we see with these animals that allow them to live here?
They stick onto the rock very tightly, and they do that in different ways. So the mussels we see here are all attaching by these threads of protein called byssal threads, and they're attached really tightly. They're kind of elastic, so you can pull them off a little bit, but they snap back. The barnacles are attached with a glue that they secrete directly onto the rock.
Right, so one of the things I was looking at is the process of how does the mussels know this is a good area to live on? Why do I want to land on this piece of rock and not someplace over there?
Typically, larvae, when they're out in the water, when they come back to the shore and metamorphose, they have some settlement cue. Some alga or an adult, the smell of an adult mussel might cue the larva to settle, for example.
I see. Is that barnacles and mussels, or?
Yeah, that's much better known for barnacles, actually, than this particular species of mussel.
Right. So if I'm a little larval swimming around over here and I get close to this one over here, this is a good spot to live in.
Right, you might taste the rock first, yeah.
So what do you mean taste the rock?
Well, they have chemical sensors on their feet and other parts of their body, so when they touch down onto the rock, they can actually taste it. It's like you were landing down there with your tongue or something.
So great tasting hamburger, for example, if a human, this is a great space, I want to live here.
Well, yeah, more like a great tasting couch, right? So.
Oh, that's right, home, very good. So I also noticed over here in this little pool, I got some chitons and I got some limpets. These chitons, where do they tend to live at? These chitons over here? Similar places as the barnacles and mussels?
Yeah, chitons all live on hard substrates, so they almost all live on rock like this. There are subtidal ones as well as intertidal ones, the ones that are constantly covered with water. This particular species tends to live high up in the intertidal, always on rock.
These chitons here that we're looking at now?
Yeah.
Before we go, this is a great area. So I got these red thatched volcano barnacles.
Yep.
Got the small ones, but I also got, I think, the bigger one right there or something.
Right, so you've got pink volcano barnacles,
right.
You've got acorn barnacles.
These little ones here.
Yeah, and then there's this even smaller ones are called buckshot barnacles.
Oh, these right here?
Yeah.
Oh, I see them. So I have this one here and I got that one.
Exactly.
And then right here, the fourth one, goosenecks.
Right, gooseneck.
I see four barnacles here.
4 species of barnacles, right? And they all do that thing where the larvae try and settle near adults, in particular barnacles, because they need to be near another adult to mate.
One of the first things I want to ask is, can mussels move around after they settle down here?
They definitely can, and they move around. They have 1 foot, and they can crawl around on it. So a lot of these small ones that are down here in the middle of the mussel bed,
okay.
You know, some other mussel might settle on top of them or move over them, and they might want to get a little bit better access to water, so they might move around to deal with that.
So I bet they can't move very fast.
No, they cannot move very fast, although surprisingly fast when they're small.
Okay.
So.
Now when they get older, can they move around much?
They tend not to move around much. They can move a little bit, they can readjust their orientation and that sort of thing, but they tend not to move around very much. They're, as you know, they're attached by those byssal threads, those protein threads, which they can actually release and make new ones. So they can move, they tend not to so much.
These mussels living in this area, they're pretty sessile, meaning again, they don't move around.
Yes.
Okay.
And the tide is coming in right now, which means that food will be here in the next hour or something.
So we call these filter feeders?
Some people call them filter feeders, some people call them suspension feeders, because they're feeding on particles that are suspended in the water.
So it's any food item in the water they're going to eat or can eat, take into their bodies?
Right, they can catch any food particle that fits in, but then at their mouth, they decide what they want to eat and what they want to spit out. So they can sort through those particles, and they try to eat the most nutritious ones.
Just one mouth somewhere inside the body cavity, right?
Absolutely, on the pointy end of the shell. That's where the mouth is.
So when I see my mussels in the stores, they open their shells a little bit, let the water in, and they have the morphology or the structures to filter the water, and then just go through.
Right, they have a couple of big gills inside the shell, and they use those to pump water through, and they pump an amazing amount of water.
So speaking of gills, they breathe water, for lack of a better term, right?
Well, they take oxygen from the water, like
right.
We take oxygen from air, right?
When they're exposed to air like this, is it safe to say they're holding their breath or holding their water, for lack of a better way?
They're actually breathing, but they're breathing using the oxygen that's in the water that's inside their shells right now.
So before the water recedes, they have to take the water, store it in their shell, and actually that's what they breathe off
Right,
of.
right. And they're definitely breathing less than when they do when they're submerged with water and actively pumping their gills and that sort of thing.
Right. So that's how they can stay outside in the air, exposed to the air much longer.
For quite a long time, yeah.
Periods.
Yeah.
So if for whatever reason they could no longer gain the water after a while, they will actually not have the oxygen and they'll perish.
Right. Well, one thing they might do is open up their shells a little bit and allow some oxygen to diffuse from the air into the water.
Oh, really?
Yeah.
Okay, so they can
reoxygenate a little bit.
I know that this is considered an indicator species called the mid-tidal zone.
Mm-hmm.
So what does that mean?
So it means that there's this particular zone of rock that's exposed to the air for a certain amount of time, and that's that zone inhabited by mussels is what we call the middle intertidal zone.
So when you see mussels, there's a good chance we are actually in the mid-intertidal zone.
Right, especially when we see dense beds of them like this.
Right. When I am out exploring tide pools and people come up and ask me what they should look for or what's interesting to see, I always like to mention what I call patterns in tide pool ecology. This refers to patterns that both plants and animals make based on the various factors, both physical and biological. Mussels form several of the most obvious and interesting patterns noticeable. This pattern, for example, shows a bare patch on a rock. But how did this bare patch form in the first place? What keeps it going? This particular bare patch is caused by limpet that is grazing on this area. As the limpet slowly moves around while it's feeding, it will dislodge juvenile barnacles and mussels and effectively prevent them from settling on this patch of barren rock. Bare patches and rocks can be formed for a variety of reasons. The barren area on this rock is caused by strong waves that have enough energy and force to dislodge all but the hardiest of settlers. Notice that the mussels can survive on the surfaces that are less exposed to the direct wave action. Mussels are very, very good at colonizing rocks and other hard substrate. All that is required for a mussel to find a good home is a good supply of seawater and a hard surface to attach to, no matter how high in the tide pool it is. I asked my friend Bruno to tell us a little bit more about why mussels seem to only live in a very narrow band in the tide pools. The mussels can live theoretically anywhere, but there's certain factors, both physical and biological factors, that prevent them from living higher and lower. If mussels live lower in the intertidal zone or actually submerged, what types of challenges or things that would keep them from living down there?
So they would actually love to be there, and in fact this species can live in the subtidal zone because then you can feed all the time, you're never too warm, you never dry out. But there are other animals that can live there that might feed on these. So sea stars, in Southern California we have spiny lobsters that love to feed on these. So there's predation affects how deep these can live in the subtidal or the intertidal even.
Primarily it's the predation that will give or make the lower boundary.
Mm-hmm.
Now the upper boundary I'm guessing it's going to be the abiotic factors, the non-biological factors, heat, availability of food, I guess. So what are some of those things they face?
Yeah, absolutely. When these are out in the sun for quite a while, they warm up quite a bit, and so that they can only survive up to a certain temperature. They dry out, they tend to evaporate water, and again, as you mentioned, they don't have much time to feed because they need to be submerged in water to actually catch food. Right. So yeah, all those sort of physical factors limit how far, and that's the reason why you're never going to find a mussel in the parking lot living, right? They can't take it.
Mussels have been used and consumed by people all over the world in many, many different countries. So where do mussels and clams and the shellfish come from? To answer that question, I'm at Catalina Offshore Products, and I have with me Tommy Gomes, who's the fishmonger, who's going to tell us all we want to know about mussels and shellfish. Tommy, I love what you have over here. Can we go around the back and take a look?
Absolutely.
All right.
Let's get wet, let's get cold in the ice.
Tommy, I see a whole bunch of shellfish over here. I think, mussels, oysters, and clams. What are the difference between these here?
Basically, it's pretty simple. It's a couple dollars a pound. That's the difference. But, you know, there's a plethora of shellfish in and around the world. Some of the ones that we have here today are the mussels coming out of Baja
Really? Okay.
are very nice. Thinner shell, sweeter in flavor, smaller nugget of meat inside. Steam up very well with a white wine Veuve Blanc or garlic lemon butter.
Very nice.
Very nice. What we have also are the oysters, farmed raised, coming out of Baja. They're a little on the briny side with a good kick at the back end of the flavoring.
Okay.
Oysters are a magnificent creature when it comes to cleansing our water, which is something that we need to be more aware of on a global scale because of ocean acidification and the fact that if you took a 35-gallon aquarium full of dirty seawater and you split it down the middle with a divider and one side was full of oysters and the other wasn't, then the side with the oysters would be clean within 3 or 4 days.
What does it mean when they're open? Does that mean they're alive or they're dead?
They're dead. So when you get them and they're open, go ahead and chuck them, throw them away. However, if you cook them and they're closed and they don't all open, that doesn't necessarily mean that they're dead.
Right.
You just want to take the good ones out that have opened up, and then the ones that are closed, cook them for just another 2 or 3 minutes and see if they open.
So how big can some of these animals grow?
Well, the giant clam, if you will, on the deep ocean floors is a massive, massive clam. These are standard issue farmed raised, but there's another clam called the gooey duck clam or the meal guy, which can be pretty intimidating if you've never seen it before.
You said gooey duck?
Yeah, gooey duck.
Gooey duck, okay.
Yeah. You want to see one?
Yeah.
So I pulled one out earlier, and this is
Wow.
the gooey duck clam, a delicacy in and around Asia, starting to really catch on here. Farmed raised in Alaska. It's planted as a seedling about 4 feet down, 6 feet down in the mud, and this neck actually goes and goes
Wow.
and goes.
Wow. So it seems the animal can't fit in this shell. Can the actual shell ever close up, or does it always expand?
Not once it reaches this size, it's always exposed. That's why it's kind of tough if you feel it.
Right.
So you pull the meat out, steam it, and then you just strip this off, kind of like pulling a balloon off of your finger. You just pull it off, and then you can slice it open and slice the animal. It's really a good tasting fish.
Tommy, thank you so much for having us out here today. I can't wait to come back in.
My pleasure. It's always fun to have you guys come in, and we hope to see you soon.
There are several companies in California that grow mussels for commercial sale. Growing mussels for sale is a long process that takes several years and lots of patience. They are grown by suspending small lines in the water and allowing adult mussels to spawn. The larvae produced by the spawning adults will attach to these small lines and begin to grow. Over the next several months, the mussels will double or even triple in size. After a few months, the mussels are thinned out and placed on additional lines where there is enough space to continue growing. Once the mussels reach an adult size in a few years, they are harvested and sent to market. Some of you may not eat mussels because you have heard that they are not safe to eat. This is true, but only in very rare situations. The reason for this is a very small planktonic animal called a diatom. Certain diatoms create a toxin that are harmful to many animals, including humans. In small concentrations, they are harmless. In very large concentrations, however, they can be deadly. Recall that mussels are filter feeders. This means that the food particles, like these little tiny diatoms that make these toxins, live in the seawater. As mussels consume these diatoms through their filtration process, they become concentrated in the tissues of the mussels. The higher the concentration, the more harmful they are to humans. In order to reach these high levels of concentrations, however, there must be huge numbers of these diatoms floating in the water. You've probably heard of the term red tide before, but may not have related the events with mussels or these diatoms. A red tide is an explosion of algae, including these little tiny diatoms that occur from time to time when the conditions are just right. The more diatoms and algae there are, the more concentrated they become in the mussel's tissue, and the increased chance of humans consuming a high concentration of these diatoms and the toxins produced by them. That is what causes the problems, and that's paralytic shellfish poisoning. I hope you enjoyed today's show, and we'll see you next time. Remember, when visiting any beach or tide pool, know the local rules and regulations, look but don't touch, and absolutely no collecting. Human impact is one of the leading causes of animal mortality in our local tide pools. Our beaches and tide pools will thank you for it.